So let's see if we can kind of do this better this time around. Friday was, I don't know. We were all over the place Friday, and I had you writing down a bunch of things that weren't even on the note packet, so I thought, let's try this again. Because it's been a week. So obviously no quiz today. What's going on? Come on. There we go. But we will have a quiz tomorrow. Sorry, I'm going to have to fix the alignment. No, tomorrow. You guys are going to be here tomorrow, right?
Oh.
No, I'm just joking.
Sure. I'll be with wrestling. I'll be at 9 a.m. tomorrow.
There we go. Okay, so here we go. Starting over. Forms of chemical bonds. You'll remember Yoda. We actually did do that part. Okay. But again, just sort of a review here, and we'll go through this first part a little bit faster because most of you were here, most of you heard this. All right. But there are two ways that atoms can bond together. Two main ways. Now, again, I think I mentioned this in the when we talked on Friday. But there's also metallic bonding. We're not really going to cover that in any sort of detail this year. Okay? So metallic bonding, don't worry too much about. The two major types are ionic and covalent. Okay? In ionic bonding, you're transferring electrons from one atom to another. Covalent is a sharing of electrons between two things. All right? Sometimes the sharing is equal. Sometimes one of the things in a covalent bond is pulling the electrons a little bit closer to itself. We'll talk more about that once we get there. Okay? But in ionic, that's more like a thief type situation. One atom comes by and steals an electron from another atom. Okay? Covalent, it's more of a sharing, like we're going to try and get along here type thing. Yes? I think so, yeah. Okay, so ionic and covalent, we're good on that, right? You guys talked about that in 8th grade. That may be one of the things, hopefully, that actually stuck with you a little bit. So we're going to talk specifically about ionic compounds for this unit. We'll take a test, and then we'll talk about covalent. All right, so we're not going to mention too much more about covalent right now. We're just going to get into the ionic stuff. Now, ionic, you've got a cation plus an anion forming a compound. All right, something that has a positive charge, something that has a negative charge forming a compound. So an example of that would be Na plus Cl minus forms NaCl. I don't know why this isn't going. In order to have a neutral compound, you need the same number of positive and negative charges. So, and again, we talked about this on last Friday. You've got sodium, which has a 1 plus charge. The chlorine has a 1 minus charge. Okay? So then that's going to form NaCl. Now, especially those people who weren't here last Friday should be paying attention right now. Okay, so one sodium, one chlorine going together, that's going to form a neutral compound because in math, and hopefully you know this, in math, that's why did I pick blue? Blue's not going to show up. I don't know how well black's going to show up. We'll try it. If you take a 1 plus a minus 1, what do you get? 0, right? Okay? That's pretty straightforward. So if you have a 1 plus and a 1 minus, you add those together, you're going to end up with a charge of 0. And that's what you want. In a neutral compound, it's going to be a charge of 0. I think I said last Friday, when you touch table salt, it does not shock you. All right? So there's no charge on that table salt. It's a neutral compound. It shouldn't shock you. If it does, you should get new table salt. Okay. So here's the part that's a little bit new because we talked about this, but it wasn't in your notes. Now it is. Okay? So how are ions formed in the first place? We need to talk a little bit about that. Remember we talked about atoms can gain or lose electrons. We talked about that when we were talking about the number of protons, neutrons, and electrons in an atom. We talked about the fact that something can gain or lose. Okay? Remember, cations, they lose electrons, so they are positive. On the video, you can't see this, but I'm making a cat paw because it's positive. Okay? So a cation loses electrons. That's the part that's a little bit tricky to remember here. to get a positive charge, you have to lose electrons, because electrons have a negative charge. Okay, so remember, electrons are like your negative friend. When they leave, when they go away, you become more positive. When they get around you, they make you more negative. Okay. Anions, they gain electrons. So this it's a little confusing. This is a dash. This is a minus sign. Okay, they're different, right? They look the same, but they're different. So gaining electrons means that they have a negative charge. Okay, so the question then is, why do elements gain and lose electrons in the first place? So we understand if they lose electrons, they're going to be positive. If they gain electrons, they're going to be negative. But why lose or gain electrons at all? What's the point? Anybody remember this from Friday? Okay, it has something to do with the noble gases, right? Okay, so I'm going to... Okay.
So they can be like the other.
So they can be like the other element.
They all want to be
Okay.
noble gases.
So combining your two answers together, they want to be like noble gases, right? Okay. Now, what is it that's special about the noble gases? Well, it's not that they're neutral. Everything on the periodic table is neutral until it gains or loses electrons, right?
Yeah.
I think maybe you meant to say stable.
Stable.
They're stable. Okay. So, and then we kind of have to think about, again, why are they stable? And it has to do with this octet rule, okay? Now, octet rule is a little deceiving because I'm going to define it a little bit differently than it's usually defined because I like this definition better. But the octet rule is a concept of chemical bonding. So it explains essentially why things bond with one another. Okay, why do ionic bonds form? Why do covalent bonds form? Why aren't the elements just happy the way that they are on the periodic table? Why do they have to combine with other elements to form compounds? Okay, and the octet rule kind of answers that. The octet rule basically says that atoms tend to react, so they have either, whoops, sorry, either part should be taken out. So they have full valence shells of electrons. So
We have it on the notes now.
is it? Okay, I just forgot to take this off the PowerPoint. Okay, atoms tend to react, so they have full valence shells of electrons. Now, full valence shell could mean 2 or it could mean 8. All right? And here's why. And I didn't put this on the notes, but we're going to talk about it. It has to do with the electron configurations, those orbital diagrams that we drew last semester. Okay? So if I've got something like, let's say, just sodium, for example. Okay? So sodium, if I draw the orbital diagram for sodium, then what I have here is I've got my 1s box, right? And above that, I'm just going to have to draw over this thing. I've got my 2s box, so this is my 2s. And then I've got my 2p's up here, okay? And then I've got my 3s box. All right, so then I just basically put electrons into this thing. And there are 11 total electrons in sodium. So the first 2 are going to go in the 1s box, and then 3, 4 go here. 5, 6, 7, 8, 9, 10, and the last one goes in the 3s, okay? So, sodium wants to have 8 valence electrons, okay? And the reason for that is because if it has 8 valence electrons, the valence electrons are basically the s and p electrons, which we're going to get to in just a minute, okay? But basically, sodium, if it loses 1 electron, if it gives away this electron in the 3s, now it has a full outer energy level. It has full s and p orbitals, and that's really stable, okay? Every noble gas has this electron configuration at the end. It has a full set of s and p orbitals, and that's a really stable arrangement, okay? The hotel likes it when there are those 8 valence electrons like that, okay? So that's why typically things will react so that they have those 8 valence electrons, the full s and p orbitals. But there are a few exceptions to that. So let's look at something like lithium, okay? So lithium, its electron configuration looks like, or its orbital diagram, I guess, looks like this. 1s, 2s, okay? Lithium only has 3 electrons, so there they are, right? Now, if lithium loses 1 electron out of its 2s, Now it's got a full first energy level, right? Everybody see that? It has a full 1s set of orbitals, and it's actually like helium. Okay? And lithium's okay just having 2 valence electrons like that because it's stable. It has a full first energy level. Okay? So that's why I'm saying either 2 or 8 valence electrons. Those are kind of the magic numbers for these things. Now, only the first few elements are going to be okay with 2. Everything after that is going to want 8. Okay? Basically, everything from nitrogen on is going to want 8 valence electrons. Okay? Everybody all right with that? Does that make sense? Okay, so either 2 or 8. And then, again, there's an exception here to that, which is hydrogen. Okay? Hydrogen only has 1 electron. Sometimes it gives up that 1 electron to form a 1+ charge, and then it has no electrons, period. Okay? So that's the one weird case that you can have where sometimes hydrogen will give up its electron, and then it's just a proton, basically. That's all it is, because all hydrogen was to begin with was an electron and a proton. If it gives away its electrons, then it's just a proton. Okay? So that's your one exception. All right, so let's talk a little bit more about the valence electrons here. Okay, the valence shell is where the valence electrons are located. In other words, it's the outermost shell. Okay? So valence electrons are electrons found in the outermost shell. I need a set of notes so I can see where you have to fill in blanks here. Did I not fix that? Yeah, sorry. I guess I didn't fix that on the PowerPoint somehow. I thought that I did. Okay, so electrons found in the outermost, this should say S and P orbitals. Okay? They're the electrons found in the outermost S and P orbitals. Okay, and we already said atoms tend to gain or lose electrons, so they have 2 or 8, usually 8 in the outermost shell. Okay? So, question is, how do we figure out how many valence electrons each atom has? Do you remember how to do that from Friday? What do you look at to determine the number of valence electrons? Close. Not the atomic number, not the mass number. It's the group number, right? The group or column number. Okay? You remember that? So you look at the periodic table for the group number. Okay? That's actually on your notes. I know it's way down there at the bottom, but that's the letter I, little Roman numeral I. Look at the periodic table for the group number. Okay, so let's look at an example of this. Carbon is our example here. Okay? How many valence electrons does a carbon atom have? So what you're going to do is you're going to look at the group number first. Okay? Find carbon on the periodic table. Look at the group number for carbon. Okay? And carbon is in which group on the periodic table? It's not up there. Okay? You have to look on your periodic table from that you made right before break. Okay, and that periodic table has the different numbers on it, and I still need to get you one. I'm sorry about that. I'll get it for you by the end of the hour, okay? Yeah, I'm going to have to print them off. Okay, so anyone have that periodic table out with the group numbers labeled? It's not 4, 14, right? Okay, remember that? Carbon is in group 14. I had you basically go through and label these right before break when we were talking about the periodic table. So you just basically count across. Group 1, group 2, 3, 4, 5, all the way up to 13. And no, I'm sorry. 12, 13, 14, 15, 16, 17, 18. Okay? So it goes up to 18 total. So it's group 14. Okay? So you look at the group number, carbon's in group 14, okay? And then if you look at the last number in the group number. That will tell you the number of valence electrons. Okay, so group number 14, the last number there is a 4, right? So that tells you there are 4 valence electrons in carbon. Okay? So the group number will always tell you if you just look at the last number in the group number. Okay, so then the answer is 4 valence electrons. Okay, so very quickly, let's do some other examples here. How many valence electrons in nitrogen? Okay, it's in group 15, right? The last number there is a 5, so there's 5 valence electrons. What about chlorine? 7. What about aluminum? 3. Sodium? 1. And calcium? 2. Okay, you see how easy that is? More than 1, 3. Oh, okay. The 3 through 12. Don't worry about the 3 through 12 for right now, okay? I'm going to give you a special rule on the transition metals in just a minute. For what, 3 through 12? For the rest of them? Yeah, I probably shouldn't have been talking. I may have to split up this group right here. This group is having trouble concentrating at the moment. Calcium is number 20 because it's in group 2. Well, 2 is the last number in 2, right? Not the last number in the atomic number, the last number in the group number. Yeah. Yes, Mike, do you have a question? You what? Oh, so you had a comment. Okay. Okay, moving on. So, how an ion gets formed. The great thing about this being on video is that you can always go back and watch the video if you missed something. All right. So the octet rule is going to tell us whether a cation or an anion is going to form here. Okay. This I wouldn't worry too much about. Okay. It's based on the number of valence electrons. Okay. Actually, no, you should write this down. I'm sorry. It's on number 3, 3A. Octet rule tells us what type of ion will form. And this is all based on the number of valence electrons. Still on the first page. The octet rule. Yeah. There's just no the in front of it. Okay. So here's an example. We want to know how many valence electrons does magnesium have, and what is its common ion. That's just another way of asking what ion will magnesium most likely form. Okay? So how many valence electrons does it have, first of all? Magnesium has 2 valence electrons. Everybody following me on that part? Find magnesium on the periodic table. It's in group 2, so it has 2 valence electrons. All right? So then the question is, magnesium wants, because magnesium's number 12, it's going to want 8 valence electrons, right? Okay? It's going to want a full set of s and p orbitals. So if we look at the orbital diagram for magnesium, just quickly, you got your 1s, you got your 2s, you got your 2p, and you got your 3s. Sorry, I'm drawing on things here, and this is hard to see. What would be a, help me out, people who are color. Red? You think red would show up better on here? Let's try red. Actually, the red shows up pretty good. Okay. All right. We like the red. 2s, 2p. Okay. So for magnesium, magnesium is basically just one more than the sodium example we did earlier, okay? So there's magnesium, right? Now, if every element, according to the octet rule, wants a full set of s and p electrons, okay, full set of s and p orbitals in its outermost energy level, then there's magnesium has a couple of options here. It could find 6 electrons and fill up the 3p orbital, right? Or it could give away these 2 3s electrons, and then it has a full 2s and 2p. Which do you think is easier for the magnesium? Probably a lot harder to find 6 electrons than it is to give away 2, right? So the magnesium is going to give away 2 electrons, okay? So the octet rule can kind of tell us what it's going to do. If it's closer to 8, then it's probably going to gain electrons. If it's closer to, 0 than it is to 8, then it's probably going to lose electrons, all right? So magnesium will... You confused about that? Why the number 8? Again, it's just because we can put 2 electrons in the s orbital, and then there are 3p orbitals, and 2 electrons can go in each of those. So you've got 4 basic rooms where the electrons can stay in that energy level. So that totals up to 8. Okay. Same thing, right? So the noble gases all have full s and p orbitals. Okay. So that's why they want to be like a noble gas, because the noble gases have full orbitals. Okay? So that's why the magic number 8. Yes, sir.
So we would have stop.
Okay. All right. Thanks. Okay. So we determine the number of valence electrons is 2. We asked ourselves, is it easier to lose 2 or gain 6? It's going to be easier to lose 2, right? Whoops. So then I put one more thing on here, I think. So magnesium would form a... Whoops. Did I mess up there? Yeah, I did. It would... I didn't mean to have the form A part in there, so cross that out. Okay, so magnesium would lose 2 electrons is what we decided. Okay, so lose 2 is what goes in the blank there. And if it's losing 2 electrons, what charge is it going to have? A positive, but be more specific. Well, that's right. It's a cation, but be more specific about the number of the charge that it will form. Okay, so if it loses 1 electron, it's going to have a 1 plus charge. If it loses 2 electrons, it's going to have a 2 plus charge. Okay? Yeah, that was a bad question. So magnesium, typically, it loses 2 electrons and forms a 2 plus charge. Okay? That's how this usually works. All right. Yeah, we'll do more of those. The next part of this, no, we're not done for today. You already labeled this on your periodic tables, right? Am I correct in saying that you labeled the charges? Okay. So notice we just went through an example where well, you didn't because you weren't here on last Friday. We just did magnesium as an example, right? Magnesium's in group 2. All the group 2 elements are going to do the exact same thing. They all have 2 valence electrons, so they're all going to tend to lose 2 electrons if there's something around that will take those 2 electrons, okay? Because then they'll be more like a noble gas, okay? So magnesium is going to form a 2 plus charge. Everything in that column will form a 2 plus. So you can label this as your 2 plus column right here, okay, on your periodic table. Everything in the column before that, they all have 1 valence electron, so all they have to do is get rid of 1. They're going to form a 1 plus charge. Okay, so everything in this column will have a 1 plus. Well, cation is a positive charge. I'm not sure. Oh, I see what you're saying. Well, yeah, it's a little confusing because electrons have a negative charge. So yeah, it does seem like you're losing electrons, it becomes positive, but you just have to keep that negative friend thing in mind. Okay? Yeah, I know. There you go. It's the opposite of what you think. Okay, these are all 0 over here. The reason for that is these are the noble gases, right? The noble gases are happy the way that they are. They have full s and p orbitals, so they don't need any more electrons. So they're not going to gain or lose, so they have a 0 charge. All right? The things in this column, they're 1 electron away from having 8. So all they have to do is gain one more electron. They'll be like the noble gases, so those are all going to form a 1 minus charge, okay? The 2 minus right here, they're 2 away from having 8. They have 6 valence electrons, so they need to gain 2 more, and then they'll have a 2 minus charge. The 3 minus over here, they have 5 valence electrons, so if they get 3 more, then they'll have 8. And so they're going to form a 3 minus, okay? That's kind of how that works. The one thing that you kind of have to remember, and I wouldn't label the whole column this way, but aluminum forms a 3 plus charge, okay? It's kind of a weird thing in group 3A, where it will regularly give away 3 electrons to form an ion. Okay? Everybody all right with how that works on the periodic table? Okay. Anything else that I want to cover today? Yeah, just a couple more things. There's one thing down here, you might remember this from Friday. You actually have to fill in this blank, okay? Where it says label your periodic table to predict charges on monatomic ions, it says metals usually form cations or positive ions, right? And so notice, everything on this side of the periodic table is going to form a cation, okay? And what's the reason for that? Well, they are metals, but why do metals form cations? And why do metals lose electrons? Okay, because they have less valence electrons, all right? So now let's talk about the ones in the middle for just a second here, because I said I was going to do this. This is not on your notes at this point. It will be a little bit later in the notes, okay, but I'm just going to mention it right now. These right here, let's say that I take SC, that's the first D element, right? It's got 21 electrons. And if I draw out the orbital diagram for SC, got my 1s, 2s, 2p, 3s, 3p, 4s, and then we've got this 3d over here. 1, 2, 3, 4, 5. Okay? So if I'm drawing out my orbital diagram for this, I guess you could do little dashes. The reason we do the up and down arrows is just to show which direction the electrons are spinning, to remind ourselves that the... Okay, so there's SC, okay? Now notice, it has 1 d electron, right? But, well, you might lose 3 for SC, that's right, so it might form a 3 plus charge. But here's the thing. When we're trying to figure out valence electrons with the ones in the middle, remember what I said a valence electron is? It's the outermost what? S and p orbitals, right? Okay, it's the outermost S and p electrons. Good. So these are the valence electrons for SC, because these are Ds right here, right? So these are S electrons. There's only 2 of them. So if I ask you how many valence electrons does scandium have? Only 2. Okay? Guess what? If I ask you pretty much for the valence electrons of any transition element, guess how many there are? 2, right? Because the rest of the electrons are d electrons in the middle there. So you can basically say, for the most part, that everything in the middle has 2 valence electrons. Okay? Now, there's exceptions to that. The exception is with chromium, the column with chromium and the column with copper, because remember, those, they take one of the electrons from the S's so that they can have full or half full d orbitals. So then those are only going to have 1 valence electron, but you don't really have to worry about the exceptions. Okay? Just know in general, yeah, just worry about the S and the P's for valence electrons. All right? So just good general rule that you can remember. This is really all you have to remember about this. The transition metals, the ones in the middle, they have 2 valence electrons. Okay? And that'll work out just fine for you. So because all of the metals have basically 1 or 2, or in the case of aluminum, 3 electrons, 3 valence electrons, they're going to give away electrons. All right? So then nonmetals usually form anions because the nonmetals typically have 5, 6, 7, or 8, right? So they're going to gain electrons to get to that magic 8 number. Okay? All right, and that's where I think I want to stop for now. So then we're gonna go over that worksheet that I gave you on Friday, last Friday. So go ahead and pull that out. If you weren't here last Friday, I'll hand it out to you now. And we're just gonna go over some of how to do that. That's what your quiz will be over on Monday. Okay?